Delaware Tech, Chemistry 100, Chemistry 110, Unit 1 continued, the metric system. So the metric system is much easier to use than most other systems of measurement. And it's easier to use because it's a decimal system. And what do I mean by decimal system? Well, it's a system based on powers of 10. Not multiples of 10. Multiples of 10 would be 10, 20, 30, 40, but powers of 10. Powers of 10 would be 10, 100, 1,000, a million, a billion, a trillion, or going smaller, a tenth, a hundredth, a thousandth, a millionth, etc. So each metric unit has two parts, a prefix, which may or may not be there, and a base unit. And the base unit is your simple unit, like a meter for a unit of length, and a prefix would tell you what power of 10 to multiply that base unit by. For example, a centimeter has centi as a prefix and meter as its base unit. So meter has a certain length. It's a little bit longer than a yard. And centi means 1/100th. So 1/100th of this meter is about the width of, say, your pinky for most people. A milliliter, milli means 1,000th, and if you look at your table of prefixes, you can see this, and I'll show you this later. But milli, 1,000th of a liter. So the liter is the base unit in the metric system for volume, and a milliliter means 1,000th of a liter because milli means 1,000th. Micro means 1/1,000,000th, and students often confuse these two because milli sounds so much like million, but milli means 1,000th. Micro means 1/1,000,000th, so microsecond is a millionth of a second, and it's the only prefix that has an abbreviation with a Greek letter, the Greek letter mu, which the Greeks call me, and it's shown here. It looks like a U with a little tail on the left side. Kilogram or kilogram. You'll hear people say kilos sometimes, just for short, but a kilogram, kilo means 1,000, and so a kilogram is 1,000 grams, and this is about 2.2 pounds, a little more than 2 pounds. If you were to compare weight with mass, which aren't the same thing, but on Earth, since we have gravity, we can do that. So on Earth, a kilogram is a little more than 2 pounds. Now, you'll be able to remember the kilo prefix because you probably heard people say, oh, I made 50K last year. Well, K means 1,000, in this case, kilo dollars. So if somebody said I made 50K last year, that means they made $50,000. Kilo is 1,000. So the prefix tells you how many times to multiply or divide by 10 or powers of 10. And here's a map of all the countries that don't use the metric system shown in red. It's the United States, Liberia, and Myanmar. Myanmar used to be called Burma. And in fact, Liberia and Myanmar have already unofficially switched to the metric system. So the only country in the world that doesn't really use the metric system is the United States of America. And it's a shame. We really need to switch to be in step with the rest of the planet and to have the same unit of measure for each of our different quantities or properties that we measure. The UK uses a mix of what used to be called the imperial system. You may know it as the English system, which is what the United States uses, and the metric system. There's also a related system to the metric system called the SI system. And the SI system stands for International System of Units. You might be wondering why the letters SI are reversed. That's because it's the abbreviation for the French words for this system, the Système International. Because the French created the metric system, as you know, so it's called the SI system. And the SI system and the metric system are very closely related. The SI system is used by scientists throughout the world, and the metric system is the version of that that's used by all the countries that use the metric system in everyday life. So let's look at some of the units of the metric system and the quantities that are measured with those units. Under quantity, quantity means the property you're measuring or the parameter you're measuring. And if we look at the base units, that's the heading on the left shown in pinkish red. There are 7 basic units of the metric system. Don't confuse this term base units with the base unit that I just said, even though those words are exactly the same. In most cases that's true, but in one case the base unit is not a simple unit. It has a prefix. But let's get to that in a second. So if we look at these quantities in the base units, we have length, mass, time, temperature, amount of substance, current, and luminous intensity. These are the 7 quantities, the 7 properties that can be measured with base units in the metric system. And what do I mean by base units? Well, they're single units. They're not composites of other units. They're not combined. They're not derived from combinations of units. They're single units. So the unit for length in both the SI system and the metric system is the meter. And the meter is a little bit longer than a yard. For the mass, it's slightly confusing. The SI unit is a kilogram. So here, the base unit for mass in the SI system is not really a base unit. It has a prefix to it, kilogram, kilogram. Whereas in the metric system, the plain old metric system, which is what we'll use the metric system unit for mass in this class, it's gram. But if you're ever doing composite units that are much more complicated, most of the time you use kilograms to build other units. Time is very simple. The unit in the SI system and the metric system and the system you're used to using, the imperial system, are all the same. It's the second. For temperature, the SI unit is degree Kelvin, abbreviated as degree capital K or small k. We're going to use the degree capital K for this purposes, but the official abbreviation is a lowercase k. The reason why we don't use that is lowercase k has other meanings in chemistry. The metric unit for temperature is the degree Celsius. And these two degree systems, these two measurement systems of temperature, are closely related. It's just they have a different starting point. The size of a Kelvin degree and the size of a Celsius degree are exactly the same. They're both significantly bigger, 1.8 times bigger than a Fahrenheit degree. A Fahrenheit degree is a smaller degree. But what's important here is the Kelvin degrees, the lowest temperature possible, called absolute zero, starts at 0 degrees Kelvin. Whereas in degrees Celsius, that same exact temperature is minus 273.15 degrees Kelvin, centigrade. Excuse me, centigrade or Celsius. Centigrade and Celsius are exactly the same thing. Celsius created the scale, and it's a scale called the centigrade scale. Centi meaning 100, grade meaning steps. So it's 100 degrees between the freezing point of water, 0 degrees C, and the boiling point of water, 100 degrees C. So Celsius and centigrade are the same. But Celsius starts at the lowest temperature as a negative number, whereas Kelvin, there are no negative temperatures. And that's why it's useful in all calculations in chemistry. Celsius can only be used in a few calculations that you're going to do in chemistry, including the very first one you're going to use in Unit 2. But those are only rare exceptions. The vast majority of calculations must be done in Kelvin when you're doing chemistry problems. The amount of substance, this is the way we count things. So we use in English the words 100 to mean 100 or 1,000 to mean 1000. Well, we have another English word, the mole. And the mole is a gigantic number, 6.022 times 10 to the 23rd. And we'll cover this more in Unit 5. But this is a giant number that's useful for counting many, many, many tiny particles like atoms and molecules. We're not going to discuss current and luminous intensity in this course, but they are two of the 7 basic units. The derived units are units that are made from combinations of the top 7 units here. So we have units like volume, which is in the SI system is a cubic meter. So meter times meter times meter is the unit of volume in the SI system, but we're going to stick to the metric unit, liter. A liter turns out to be 1/1000th of a meter, of a cubic meter, but we're going to stick with liter. And if you want to think what a liter looks like, a liter is a little bit more than a quart. It would be a box, a cubic box that you would make if each side of the box was about the length of a cigarette. Density is a measurement of mass per volume. So the units are always some unit of mass divided by some unit of volume. In the SI system, that's kilograms per meter cubed, but we're going to be using the metric units for density, grams per milliliter, or grams per centimeter cubed, or grams per cc. Those three things are all identical because milliliter, 1,000th of a liter, is exactly the same as a cubic centimeter, which is exactly the same as a cc, because cc is just an abbreviation for cubic centimeter. Energy comes in many, many forms, and we'll talk about these later. We have forms called potential energy, kinetic energy, which is the energy of movement, work energy, heat energy, and these all use the same unit in the SI and the metric system called the joule, and that's abbreviated as capital J. And pressure comes in many, many units that you're going to see beyond the units of the SI and the metric system. But in the metric system and the SI system, the unit is the Pascal, named for the famous mathematician and philosopher Pascal. A number of other units are on here. We're not going to discuss these here. The ones in orange relate to radioactivity, which is discussed in Unit 10 if you're taking Chem 110. And the others are in more advanced courses for chemistry. So let's talk about how big these units actually are so you can picture the size of various metric units. As I already stated, a meter, it's slightly longer than a yard. It's 39.37 inches as opposed to 36 inches for a yard. So only a little bit longer, only a few inches longer. Our mass unit is the grams in the metric system, and that's about the mass of a raisin. The raisin has a mass of about 1 gram. Time, you already know roughly what a second is, so I'm not going to go over that. Temperature, we're going to be doing conversions from Fahrenheit to Celsius or centigrade, and conversions of Celsius or centigrade to Kelvin. And energy, as I already mentioned, is measured in joules. You may have heard of another unit of energy called the calorie, and we'll discuss that also in Unit 2. Volume, as I said, is the unit, the metric unit is the liter. So think of a 2-liter bottle of soda and cut that in half. And then the amount of a substance, the mole, that's the very large number I talked about before, and we'll talk more about that in Unit 5. So here are the prefixes that are used in the metric system as well as in the SI system. And we're not going to look at every one of these units, every one of these prefixes, but these prefixes all have names on the left. They all have symbols. Most of them are 1-letter symbols. One of them has 2 letters, deca, which is DA. It's more commonly abbreviated as capital D, so I should add that in there. And but the ones I want you to focus on are in the red box here. And these are the ones that go up to 1,000-fold, which is kilo, and go down to a millionth, which is micro. And a way to remember these abbreviations for 1,000, 100, 10, the base unit, which is just 10 to the 0, which means you're multiplying it by 1, which really means you're not changing it at all. Deci, which is 1/10. Centi, which is 1/100th, that's 10 to the minus 2. Milli, which is 10 to the minus 3. Again, don't confuse milli with million. Milli means 1,000th, not 1 millionth, and micro means millionth. And a way to remember these prefixes is this little mnemonic here. Kings hate dragons because would be your base unit. Dragons can't make money. And if you go online, you'll find a lot of different mnemonics for this. Pick the one that helps you remember if you're having trouble remembering these. But kilo is easy to remember. Kilo dollars, when people say they made 50K, it means they made $50,000. Deci is a tenth because deca and deci come from a word that means 10. Centi, as in 100 cents in a dollar, means 100th, because a penny is 100th of a dollar. That's why we call it a cent. Milli is 1,000th. Micro is a millionth. And again, it's the only prefix that is a Greek letter mu. So let's look at some examples. Kilo, meaning 1,000-fold, $1,000. Deci, Way to remember that, if you don't already know that deci is related to the number 10. The word decimate, actually, we think of the word decimate with its modern definition meaning to destroy everything. But the original meaning of that was to destroy 1/10 of everything. And the reason for this is in ancient Rome, there were a few generals in ancient Rome when they were very, very displeased with the actions of their soldiers. If their soldiers weren't brave in battle, sometimes they did a horrifyingly evil punishment, which is they would make everybody draw stones from a cup, and whoever got the white stone out of 9 other black stones would be killed by their 9 friends. And as a result, if you had an army, suddenly 9/10 of the army was killing the other 10th of the army as punishment to the whole army. So that's where we get the word decimate. It literally means destroy 1/10. Centi, again, I said cent. Milli, don't confuse with million. Micro, the only Greek symbol. And nano is a billionth. So you can see 1 over a billion, or 10 to the minus 9. And nano comes from the word that means tiny, which makes sense. As we go larger, kilometer. So kilometer is, or kilometer, but most people say kilometer, means 1,000 meters. Literally 1,000 meters. The name tells you what it is, if you know the prefixes. And a kilometer is a little bit less than a mile. It's about 11 football fields. A meter, again, is slightly longer than a yard. A decimeter, a 1/10 of a meter, is the length of a cigarette. Centimeter is a little less than half of an inch. And in fact, there are exactly 2.54 centimeters in an inch. An inch was actually defined in the past 50 years, defined based on the centimeter. A millimeter is the width of a paper clip. Another way to think of it is if you took your index finger and your thumb and you tried to hold them as close together without them touching, that would be about a millimeter. So the metric system, or the SI system, this is really our universal language for measuring things among all the scientists and most engineers around the world. And we have our base units in the metric system, the grams, liters, for mass and volume, respectively. And meters for length, seconds for time, and degrees Kelvin for temperature, also degrees centigrade for temperature, Celsius for temperature as well. So converting units within the metric system, these are always exact conversions because they're based on powers of 10. And I've shown here the prefixes. So on the left is the mega, meaning 1 million. And then I have 2 spaces for the next 2 powers for 100,000 and 10,000, which we're not going to be responsible for. K for 1,000. H is hecto, meaning 100. Capital D is the deca, also known as little da, but we're going to use capital D in this case. Then you have the base unit, so the base unit might be gram or liter or meter or second. And then we have deci, which is the lowercase d, meaning 1/10. Centi, meaning 100th. Milli, meaning 1,000th. And then there's nothing for 10,000, nothing for 100,000. We get to a million, and we have mu, the Greek letter, mu meaning a micro or a millionth. And then we skip 2 more to get to a billionth, which is nano. So if you wanted to convert these, you just keep track of the spaces, and each space is a power of 10, or the movement of 1 decimal place. So for example, if we wanted to convert 5.6 meters to millimeter, well, we would look where the meter is, and let me see if I can get the pen to work here. We look where the meter is, and we want, the meter would be a base unit, and we're going to millimeters, so it's a little confusing because this would be our meter, our base unit, and this would be our prefix, millimeter, not meter. That's milli. That's the prefix, meter, milli. So that's 3 jumps. So we're going from a big unit to a small unit, so our number has to go from a small number to a big number. If we have a small number of a big unit, we're going to end up with a large number of a small unit. So we're going to be making 5.6 bigger by 1, 2, 3 powers of 10, and therefore we would get that 5.6 meters equals 5,600 millimeters. Or you could just remember that a millimeter, there are 1,000 millimeters in a meter, so you just multiply 5.6 times 1,000. 25 milligrams is a hundredth of a gram. And we want to convert this to millionths of a gram, microgram. So we're starting from milligram here, and we're going to microgram here. Oops, microgram here. Again, it's 3 jumps to the right here, so we're going to a smaller unit, and again, we're multiplying it by 1,000. 3 powers of 10, 3 movements of the decimal place. So we end up with 25 milligrams becomes 25,000 micrograms. And for those of you worried about dosages, this can be very important. 4,500 liters, or 4,500 liters, going to kiloliters. So we're starting from the base unit, liters in this case, and we're going to kiloliters, which are 1,000 liters. So if we've got 4,500 liters, how many thousands of liters is that? Well, we're going this direction now. We're going from liters all the way to kiloliters. So we're going to a much, much bigger unit. So our number must get smaller by 3 hops, 3 powers of 10, 3 decimal places. So this would be equivalent to 4.5 kiloliters. And then our last example here is 5,600 or 5,600 decameters, and we want to go to megameters. So we're starting from decameters, and we're going to megameters here. Megameters. It'd be a capital M and then a lowercase m. And don't confuse the capitals and lowercases because in chemistry, as well as in all sciences, the abbreviations have very specific meanings, whether they're capitalized or they're lowercase, so it's important to keep track of when they are. So I'll just write it down here so it's not over top. It's a little hard to see. So we're jumping 1, 2, 3, 4, 5 decimal places to a much, much bigger unit. So if we're going to a much bigger unit by 5 decimal places, then we must be having a number that is 5 powers of 10 smaller. So we move the decimal point, and we could start with 5,600. We could do it this way, 5,600, and put the decimal place where it used to be. And now we're going to make this number smaller by 1, 2, 3, 4, 5 powers of 10. We'll put a decimal point there. We'll fill in the 0. And we'll fill in the 0 here, we'll rewrite the decimal point, and we end up with a number of 0.056, and we don't have to write these in this case, 0.056 megameters. And in scientific notation, we would rewrite it like this. Now, there's another way to do this. You can take this in 2 steps. So I'm going to erase this now. And you can start with the deca and go to the base unit first. Now you might think, well, wait a minute, that's the wrong direction, but that's okay. We get to the base unit, so it's always easy to convert to the base unit. Decameter, deca means 10. So if I have 5,600 decameters, well, deca just means 10. I can just replace that with times 10. Oh, so that means I have 56,000 meters, which I've written here. Actually, I haven't written here. It's 56,000 meters. So we know in the base unit, and now converting the base unit to the new unit, megameters, that's mega, 1,000,000 meters. So now we just divide this by 1,000,000, because there are 1,000,000 meters in a megameter. 1,000,000 meters per megameter. And if we divide that out, we'll get the exact same number. So you can do this either way. Practice these. Get used to moving up and down with the prefixes. It's going to be important when you're doing your metric to metric conversions. But there are many kinds of conversions. And here is shown in the non-scientific notation what we call the decimal format.